Okay, I got to record another video. I think I just had a little bit of a breakthrough. Um, and I say this, I got to be careful how I say this, but I think I can prove that dark energy does not exist. Okay? I can prove why the universe started expanding slowly and then accelerated. And I can tell you that the universe will most likely slow down in its expansion based on what we've been talking about. Now, let's just think about this for a minute because there's a lot to unpack here. Dark energy is basically a label or an excuse for our inability to explain why space is expanding, why the universe is expanding, and why that expansion is accelerating. The acceleration specifically is what dark energy supposedly is. It's the force that's creating or causing this acceleration. Now, we can't explain that, but yet what we're seeing here is this clear acceleration and deceleration through a gradient that was created by pi. It's a pi gradient. I mean, I call it psi pi because it's a different approach to pi, but nonetheless, it is pi, as I've said in previous posts. Um, so we've got pi, the fine structure constant, and the golden ratio, which all kind of give us this acceleration deceleration model. And one thing to note in that all quantum mechanics and all these equations of special relativity, everything involves pi, only it's using a static value of pi. So you're not, you're that static value of pi has an effect on those equations. It absolutely has an effect on those equations. And you're going to, so an example of that might be why they didn't expect the expansion of space to be accelerating. It was longly accepted that space was expanding, but at a uniform rate, which, from the sounds of it, sounds like that's the behavior of a constant, right? You have a uniform growth, that's a constant. The acceleration they couldn't explain. When they measured it, they couldn't explain it, so they created this dark energy as a way to explain why the universe is accelerating. Now, again, in the context of what we've been talking about and what we've been observing in this sci-pi equation, in the sci-fi formula, um, I think the correlations are pretty striking at this point. Now, I can't say that this is, you know, 100% validation, but there's a strong correlation here that needs to be explored. And I felt like I needed to record this right away because once this kind of came to me, it was like, um, it's definitely something that's very, very intriguing at very least. And I don't think that anybody outside quantum mechanics and these relativity equations, Schrodinger equations, wave functions, all of these things that they use to predict, um, the quantum effects on things. I just there's obviously connections because these numbers are lining up so perfectly, and the behaviors are lining up so perfectly. Um, I can actually show you pretty quickly that, and I should have had this loaded. I should have, but I'll have to put it in a different video. But I can tie gravity into this beautifully, right? I mean, gravity literally falls out of these same numbers and formulas. Um, at least the value that we measure as gravity. It's really quite striking how many things are lining up and how perfectly they seem to be lining up. And again, I think the dark energy side of things. I mean, the inexplanation of that and using pi as a constant, as a static number that never changes. I think that creates the gap that allows for the misunderstanding of dark energy. So again, I think that dark energy isn't real. I think that this explains why dark energy isn't real, and that what we're seeing is that even though space might be expanding and accelerating now, it will slow down at some point. And again, that comes back to the how many revolutions there are on the negative side before it starts to slow down. These things have to be kind of worked out and figured out. But it's a really interesting spot to be for sure. So I'll leave it at that for now. And again, I've put up the links. I'll put it up again. You can test it out yourself. Don't take my word for it.